All right, today we'll be going through some of the remainder factor theorem questions. This will revolve around this main theory that fx, which is your function, is always equal to your quotient times divisor plus remainder. So when we have a factor, r will always equal to 0, and we simply substitute in the factor as equal to 0. For example, the factor of x plus 2, and we can substitute this value of x equals to -2 to determine the certain values that are unknown. So let's look at the application of this theory here into this question. So let's begin with question 9a. They tell us that x plus 2 is a factor, which means that we have a remainder of 0. So x plus 2 equals to 0, x equals to -2. We must substitute x equals to -2 into the function, and we'll get 0. So 8 times -2 cubed plus 8p minus 2 squared minus 24 times -2 minus 16 equals to 0. We will have minus 64 plus 32p minus 48 minus 16 equals to 0. So we have 32p minus 32 equals to 0. 32p equals to 32, p equals to 1. So with that, we have gotten the first 2 marks of the question. Now, once we know the value of p, they want us to find the quotient and remainder when fx is divided by 2x minus 1. So let us rewrite fx with the found value of p. So fx is actually equal to 8x cubed plus 8x squared minus 24x minus 16. So when it's divided by 2x minus 1. So here we want to apply long division. So we have the whole thing, 8x cubed plus 8x squared minus 24x minus 16 divided by 2x minus 1. So using long division, we can actually solve the equation. So we have here, we have 4x squared. So we minus 8x cubed minus 4x squared. And then we get 12x squared minus 24x minus 16. Then we continue with this. We divide by 2 again. We get plus 6x. We plus 6, we minus again. We have 12x squared minus 6x. Again, 12x squared minus 12x squared, 0. We have minus 24 plus 6. We have minus 18x, which minus 16, which now becomes minus 9. So we have minus 18x minus 9, which is, plus 9, which is now minus 25. So we have the one on top here, 4x squared plus 6x minus 9 as our quotient. And this minus 25 here as our remainder. All right, so with that, we have done question 9b, which is worth 4 marks. Now we're going on to question 9c. Solve fx equals to 0, giving your answers in surd form where possible. So let us continue with this equation as general. We have, once again, to rewrite fx in the full form which we have determined, which is 8x cubed plus 8x squared minus 24x minus 16 equals to 0. We can divide by a common factor of 8 throughout to get x cubed plus x squared minus 3x minus 2 equals to 0. From here, we can use 2 methods, either synthetic division, comparing coefficients, or perhaps if you want a third method, which would be long division, but I wouldn't recommend that. Instead, we can just move back on to synthetic division, where we can use the factor given here, x equals to -2 to help us. So x equals to -2 here, we write the coefficients down of all the powers. And we begin working 1 times -2 is -2, minus 1, which is 2. And then -1 times -2 again, 0. So we have x plus 2 times x squared minus x minus 1 equals to 0. So we have several different answers now. We have x equals to -2, x squared minus x minus 1 equals to 0. So here they give us a hint. They tell us, give your answers in surd form where possible. So it is good that we have a non-factorizable form of an algebraic equation here where we cannot do any further factorization. Instead, what we can do is apply our quadratic theory, which is minus b plus minus b squared, square root of b squared minus 4ac over 2a. So substituting it, minus 1 is 1 plus minus b squared minus 4ac minus 1 squared minus 4 times 1 times minus 1 over 2. 1 plus minus square root, we have about root 5 over 2. And there we can see the answer is here. So once again, we have finished off this part here with the 4-mark question solved. All right. Now moving on to question 4, which is once again another remainder factor theorem question. Instead, this time we must compare the remainders. So they tell us that there's a certain function here, which has the same remainder when divided by x minus 1 and x. When it's divided by x minus 2, it leaves a remainder of 3. So here we can say, let remainder of px be r when divided by x minus 1 and x. So once again, we want to substitute the value of x equals to 1 and x equals to 0 into the equations, where we'll have r as the answer. So looking at that, we have a minus 4 plus b plus 5 equals to r. A plus b minus 1 equals to r. We have x equals to 0. So this will become 0. This will become 0. This will become 0. This will become 0. 5 equals to r. All right. So we have a plus b, plus 1. Plus 1 equals to 5 because r equals to r. And therefore, these equations can be written like that. So a plus b equals to 4. With a plus b equals to 4, we can then need to create another simultaneous equation to solve it. So they tell us down here that when divided by x equals x minus 2, px leaves a remainder of 3. So when x equals to 2, we have this situation where we have a 2 cubed minus 4 2 squared plus b times 2 plus 5 equals to 3. So we have 8a minus 4 squared minus 16 plus 2b plus 5 equals to 3. 8a plus 2b equals to minus 2 plus 16, 14. So we have 4a plus b equals to 7. Now here we have a plus b equals to 4. 4a plus b equals to 7. This is equation 1. This is equation 2. We take equation 1 minus equation 2 to get 4a plus b minus a minus b equals to 7 minus 4. 3a equals to 3. A equals to 1. We can substitute that in. B equals to 7 minus 4a. B equals to 7 minus 3 equals to 4. Therefore, we have a equals to 1. B equals to 4. 5 marks has been obtained. So once again, what we're doing here is using the remainder factor theorem. Using the remainder factor theorem here to solve and find simultaneous equations. So let's look at the question as a whole again. We have used the substituted values of x equals to 1 and x equals to 0, x equals to 2, to form 2 different simultaneous equations, which we are then able to use to solve the final equation and determine the values of a and b. So now moving on to question 4, part 2, which actually involves us using long division. So what does that mean? We can substitute the values of a and b, which we have found. In this case, we have x cubed minus 4x squared plus 4x, plus 3. Oh, my bad. It's not 4, it's actually 3. So b equals to 3. B equals to 3. Plus 3x plus 5. And we want to divide the whole thing by x squared minus 5x plus 6. So once again, we're going to apply the same thinking that we've learned in long division. X cubed divided by x squared, we get x. So times the whole thing again, minus 5x squared plus 6x minus divide. We get x squared minus 3x plus 5. Divide again, we get a plus 1 to get x squared minus 5x plus 6 minus the whole thing, we get 2x minus 1. So the remainder in this case would be at the bottom, which is 2x minus 1. And we have gotten our 3 marks and 5 marks for a total of 8 marks. So you can tell these are very good questions to score in using simple concepts, which they may just phrase it differently. But overall, it involves substituting in a certain value, if not substituting in some kind of, what do you call it? Synthetic division or long division to solve the equation. So now moving on to question 3, which is actually labeled question 1 here, but never mind. So they tell us the polynomial 2x cubed minus 3x squared has a plus blah 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 has a factor of x minus 1 when divided by x plus 2 as a remainder of minus 54. So once again, we're using our remainder factor theorem here to solve the question. And then there's another part of the question which says, hence find the remainder when the polynomial is divided by x squared minus 4. All right, so we can remember that we always set the factor equals to 0. So x equals to 1 and x equals to minus 2 are the appropriate values to substitute in for this equation. So when x equals to 1, we have a situation where we have 2 minus 3a plus b equals to 0. So minus 2a plus b equals to minus 2. 2a minus b equals to 2. Simple algebraic manipulation. We have x equals to minus 2, where we have 2 times minus 2 cubed minus 3a minus 2 squared plus a times minus 2 plus b equals to minus 54. From there, we can simply expand everything out, where we have minus 14a plus b equals to minus 38, which we can then solve by doing an addition. If this is 1, this is 2. 1 plus 2 will give us minus 14a plus b plus 2a minus b equals to minus 38 plus 2. Minus 36 equals to minus 12a. A equals to 3. Therefore, b equals to, we just do some simple substitution. We get b equals to 4. So working is on this side here. B equals to 2a minus 2. So b equals to 6 minus 2 equals to 4. Here. All right, so we have the first part of the question done. They tell us, hence find the remainder when the polynomial is divided by x squared minus 4. So here we can continue on this other slide here by rewriting it as fx. Once again, we want to go back to our thinking, which is that we have the quotient times the divisor plus remainder. So in this case, we have a polynomial of degree 3 as implied by the 2x cubed. So if we divide a degree 3 by a degree 2, in this case, x squared minus 4, we end up with a degree 1. So the remainder in this case will be a ax plus b form, which is a linear equation. All right, so we have 2x cubed minus 3 times 3 minus 9 x squared plus 3x plus 3x plus 4. Sorry, these things keeps popping up. So annoying. Equals to qx, which is x squared. It's just x squared minus 4 times qx plus ax plus b. All right, so x squared equals to x squared minus 4 equals to 0, x squared equals to 4, x equals to plus minus 2. So we can substitute either one of those values. For simplicity's sake, I'll substitute x equals to 2 because we won't have to deal with the negative signs. So we put in 2 times 2 cubed minus 9 times 2 squared plus 3 times 2 plus 4 equals to whole thing will become 0. So 0 plus 2a plus b. In this case, we can substitute in the values. Hold on, my screen is lagging a bit. To get 2a plus b equals to minus 10. And then now we realize that we have an equation on this side, but we have two variables, a and b, which means that we can't solve it without forming another equation, which is why, thankfully, in this situation, we actually have another value that we can substitute in, which is actually x equals to minus 2. So we substitute x equals to minus 2 in, we will have a separate answer where we have something that equals to minus 2a plus b. So we substitute minus 2 into all the values of x, we will have minus 2a equals to minus 54. If this is equation 2, this is equation 1. We take equation 1 plus equation 2. We have 2a plus b minus 2a plus b equals to minus 10 minus 54. We have 2b equals to minus 64, b equals to minus 32. And we can substitute this back into a to get a as 11. So the remainder, which is ax plus b, is actually just 11x minus 32. All right, so this one is a bit more messy. My apologies for that, but let's just do a quick review of what it is. We are reviewing the remainder factor theorem ever so slightly again, as it is, after all, the name of the topic. We have x squared minus 4 as our divisor in this case. So we want our divisor to equal 0 to get our remainder, which in this case is ax plus b. Why do we know it's a linear factor? Because we go back to the question itself, which tells us that it is a degree 3 polynomial divided by a degree 2 equation, which is x squared. So we have a degree 1, which in this case would be linear. Then moving back to the previous part of the question, part A, we are involving substituting in values of x to find the remainder. Once again, using our key principle of remainder factor theorem, is that when our divisor is equal to 0, we'll find our remainder by substituting in the value found here. All right. So that is all for this very quick 3 questions. Thank you so much.